Start recording. What we're going to do, to be able to do this, we are going to do something called splitting the middle term. Okay? There are other ways to do it. There's like a trial and error method, but this way is probably the most efficient way, most effective way to do it. So what we are doing is we are learning a technique for factorising a quadratic where the x squared coefficient is not equal to 1. Okay? So, just to summarise what we've just been doing, and so it's on a video for you as well, if I want to factorise a simpler one, so let's say x squared plus 7x and then minus, what can I have, 30. So this one is a simple one that we've done before. How would you tell someone how to do it? We've already done this once, so what would you do? Hey.
First, I would look at the 30.
So we look at this minus 30.
And I would say what makes minus 30. And I
So
would say
what makes, but also what multiplies to make.
Yeah.
Okay. So our options are
1 and 30, 2 and 15,
1
3
times
and 10.
30, 2 times 15, 3 times 10.
I would see 3.
Don't forget 5 times 6. Just
And then I'd look at the 3 and the 10 and I'd say, well, 10 minus 30 equals 7.
okay.
And since I need a negative, well, all of them can have a negative.
Well, so what I would be, just to add to that, just to help anyone out, is this is a negative, which means one of those numbers has to be negative to help you decide if the term in the middle is a positive. That's the result of adding two of the numbers together. That means the bigger number must be positive. So it's either minus 1 times 30, minus 2 times minus 3, or minus 5. So we're then looking at whichever one of these adds to make plus 7. Okay? Yeah?
Could it not be like not saying like because of that, but like, would it always be the smaller number that's a negative?
No, so if this was minus 7x,
Then it wouldn't. Okay.
it would be different, yeah. So it's more that the fact that the middle term is positive, that sets out that the smaller must be negative. So I'm looking for those ones that add to make positive 7, so it's quite nice, and we can see that minus 3. Okay? So then that would lead us down the path of, well, it's x minus 3 and x plus 10. Alright, happy with that? Now what I'll do is, just because we're looking at splitting the middle term.
Wait, sorry.
Go on.
Is it because the 3 and the 7 equaled 10 or something?
Yeah, so minus 3 add 10, because that's a
Is
positive,
7?
makes the positive
Okay.
7, yes. Right, if I write it out by splitting the middle term, I've actually got x squared minus 3x plus 10x minus 30. Now this is what we're going to be using our splitting the middle term. By splitting the middle term, what we can actually do now is cut our quadratic in half. Alright?
Oh, I remember this.
Remember doing this now. Alright? We don't necessarily need to do it in this case because we've gone straight to our answer, but just to show you it still works. Do you remember how when we were doing the thing at the start, the factorising, we can group some together, take a factor out and then a different factor out of the other half? Well, we can do the same thing here. So by splitting the middle term, I can now factorise this half, and it becomes x times x minus 3, yeah? So I've factorised just that half. Then this half becomes what?
10. Bracket.
10 brackets x.
Subtract minus 3.
Okay. And of course it's a positive 10, so we've got positive 10. So do you see how that works? So I've split the middle term and I've factorised. Now this is also then an important skill for you to understand what you're doing. I am now going to factorise a second time.
I just like, I don't know. Are you gonna do the x minus 3, and since that's a factor, are you gonna?
Yeah.
Okay.
So what's the common factor now?
X is
X minus 3. So I'm going to take the x minus 3 out, and I'm left with the
X
x
10.
plus 10.
And then you work it out and then you do
Well, that's it, isn't it? That's factorised now.
Oh.
So I've done, by splitting the middle term, I factorise once, okay, but then I factorise again.
But you literally just wrote like.
Alright, so just to show you, in this case, I've split the middle term, and then I've taken, oh, didn't want to do that. I've taken a common factor of x out of this one, right? And then I've taken a common factor of 10 out of here,
So it becomes 3.
right? Then, on the second go around, I can now take a common factor of x minus 3 out and bring that outside, and I'm left with my x plus 10 that I had before. Okay, so I factorised twice. So that's how I do it, by splitting the middle term. Okay. Yes.
I don't know, maybe this is a really stupid question, but I don't get why we're doing that, because we're like, literally like coming out with the same result that we started.
Right, okay, so yes, like I said, you wouldn't bother in this case. However, what are we going to do next?
Should more when x is
Exactly.
equal to 1.
So what I've done for you, hopefully, is I've used the method in a situation you already know how to do. Hopefully that makes it easier to understand what's happening. Right? So yes, you wouldn't, just to be clear, you don't need this method to solve this one, do you? Okay? But we might want to use it next time round. So what we'll have a look at, go on, question.
Why are some X's in yellow and some aren't? Like what's
Well, because
the
I've
yellow?
taken a common factor out here, the x
Okay.
is that one, and I've taken a common factor of 10 out
Okay.
here.
But that X just is nothing.
That's this x, yeah?
The one over there.
This one.
No, up. Like that. Yeah, that one.
Well, that's this one in here, isn't it? It's the x.
Okay, yeah, sorry.
Right, so what I'm going to do, I'm going to have a look at this question now. 3x squared, I will, but I'm going to rewrite this. 3x squared plus 14x plus 15. Okay, so we are now going to do a different one. 3x squared, what was it, 14x plus 15. Okay, so we want to factorise this. We're going to factorise this one. Now, what's not true in this case?
So the coefficient of x squared is 1.
Okay, so the coefficient here is now no longer 1, it's now a 3. Now, unfortunately, that changes our rules that say...
Wait,
Yeah?
sorry. Why is that minus negative 3x? Never mind, I get it. No, I'm good now.
Okay. So in the black one, what's unfortunately no longer true is that I can no longer use the rule that says two numbers multiply to make 15 and add to make 14. That no longer works. Alright? Because if I think about it, in my double brackets, why can it no longer be x and x?
Because it's
Because we've got 3x squared. Now actually this case is alright because there is only one way to make 3x squared, and it would be x times 3x. So I kind of know that the brackets are going to be x and 3x. Now the trouble is, not the trouble, that because I know that that's 3x, well if let's say I've got plus something and plus something, it used to be that this number was just multiplied by an x and this number was multiplied by an x and we add them together. But now this one is multiplied by 1x, but this one is multiplied by 3x's. So we haven't got the situation where we can just add the two together anymore. So I'm no longer looking for a situation where they multiply from 15 and add to make 14. Because I'm sure you've noticed that that won't work, will it? I can't multiply to make 15 and add to make 14. It doesn't work. So what I'm going to do is this method. You might need to follow this through very carefully. The method is, we start by taking the coefficient of A and you multiply it by the coefficient of C. So I actually do 3 times 15 equals what? 45. Okay. So this is the only extra step we need really. Now we actually need something that multiplies to make 45 and adds to make 14. So it's no longer multiplies to make 15 and adds to 14, it's multiplied to make 45.
9 and 5.
So we've got 9 times 5 does indeed make 45. And 9 add 5 does indeed make 14. Well, what we do now is we split the middle term. Okay, so I'm going to split the middle term and I'm going to do it like this. So I've got 3x squared, and it doesn't matter which way round you do it. I can do plus 9x plus 5x and then plus 15 again, not the 45. Yes? Question?
So, could that one be the question mark there be?
Well, let's not try and guess them. Let's just go through the process. Right? So I've split the middle term, just like I did up in the previous one. Alright? I need to split this in half now. And I need to do my double factorisation. So, factorise this bit for me, I get
3x bracket x 3.
and then the other side will be plus 5.
Bracket x 3.
Now the tip is, when you're up doing this, whatever brackets you get there, it'll be the same brackets there. So you kind of just gives you a clue. If you end up with 2 different brackets, you've done something wrong. Okay. Now I need to factorise a second time, and I get x plus 3.
3x plus 5.
Oh yeah,
3x
that's
plus
right.
So you were right. Okay.
Does math figures now, right?
Pardon?
Never mind. Sorry.
Now, just to show you, if I'd have done it differently, if I'd have done 3x squared plus 5x plus 9x plus 15, do you think I would have got a different answer? If I'd just written the 5x and the 9x the other way around?
Should we write that? Yeah. The other one.
Well, I tell you what, let's think rather than just write. What happens? So can we do it again just with the term split the other way around, just to show you? So split it. This factorises to what? X and
3x plus 5.
It works.
okay. This one goes to 3 and 3x plus. And we refactorise, and this time we get 3x plus 5, and you just get it the other way around. Right? Which of course, because it's multiply, you can do it either way.
How did you get rid of the 14 in the middle?
I didn't get rid of it, I split it. 9 plus 5.
So then what was the point of doing the 9 times?
So I did, to be able to split the middle term, Alan, I did 3 times 15 gives me the 45. I needed to then know 2 numbers that multiply to make 45 this time, not the 15. 2 numbers that multiply to make 45 and add to make 14. And it just happens to be 9 plus 5, 9 times 5.
Okay.
And then it's those 2 numbers which I used. Okay, so 14 was split with 9 and 5, which then we split the middle term like that. So that's why it's called splitting the middle term. Right. How are you feeling with that?
Wait, why did you times 3 times 15 in the beginning? I got the answer.
Because of this impact that the 3x has on the middle term. So, do you know, remember I said the 3x times the bracket, so you will still notice that in the final result there, that 3 times 5 does still give me 15. So the 45 bit is just so I can find what adds to make the middle term.
I just needed to know.
Yeah. So why don't you guys then have a go at one of the other 2. So maybe if you're going to work next to someone, do the other one. So one of you have a go at 5x squared plus 27x plus 10, and the other one have a go at 3x squared plus 17x plus 25. And we'll scroll up once people. Okay, I'm recording. Right, first one then. First step is 5 times 10. Okay, makes 50. So that's the 5 times the 10, makes 50. So I've got to work out what multiplies to make 50, adds to make 27. It's quite obvious, I think. 25 times 2 and 25 plus 2. So I've got 5x squared plus 25x plus 2x plus 10. I've split the middle term. I get 5x times x plus 5. And over here I've got plus 2 times x plus 5. Which if I factorise again, I get 5x plus 2 brackets x plus 5. So, yeah.
So if I would switch the 2 and the 25 around, how would that work?
Or you'd end up with the same thing.
I know, but like, can you just show us?
So if you had 5x squared plus 2x plus 25x plus 10, split it, I would then just factorise it with x times 5x plus 2 plus 5 times 5x plus 2. Okay. If you've done your one, that's fine. So did everyone who did that one get it right? Cool. Right, the next one then, just to go through it very quickly. 3 times 24 is
72.
72. So we find
9 times 8.
so 9 times 8 and 9 plus 8. So we've got 3x squared plus 9x plus 8x plus 24. Split it, gives me 3x, x plus 3, plus
8.
8,
Bracket x plus 3.
x plus 3, gives you 3x plus 8 and
X plus
x plus 3.
I got it.
You got that right?
Yes.
Brilliant. Right, what we'll do next time is solving quadratics. Make sure you're happy, and I'm recording this so I've got proof. Make sure that you're happy with your factorising. So if that means you need to go and do a few more at home or come and have a chat to me or whatever, make sure you do it. If you're perfectly good, you've got no more to do. If you're not, do some practice.